It has enabled the development of systems that can learn, adapt, and make decisions on their own, without the need for explicit programming. Deep learning algorithms include convolutional neural networks, CNNs, recurrent neural networks, RNNs, and deep belief networks, DBNs. These algorithms have multiple layers of nodes, which enable them to process more complex data and make more accurate predictions. Neural networks are a key component of deep learning algorithms. They are composed of layers of interconnected nodes, which are modeled after the neurons in the human brain. The basic unit of a neural network is a node, which receives input from other nodes or external sources, performs a mathematical operation on the input, and produces an output. Nodes are arranged in layers, with each layer processing a different aspect of the input data. The input layer receives data from the external world, such as images, text, or sound. The output layer produces the final result, such as a classification or prediction. In between the input and output layers, there can be one or more hidden layers that process the input data to identify relevant features and patterns. Neural networks are trained using a process called backpropagation, where the error between the predicted output and the actual output is propagated backward through the layers of the network, and the weights of the connections between nodes are adjusted to minimize the error. There are various types of neural networks used in deep learning, including feed-forward neural networks, convolutional neural networks, and recurrent neural networks. Each type of network is suited for different types of tasks, such as image recognition, natural language processing, and time series analysis. Convolutional neural networks, CNNs, are a type of neural network commonly used in deep learning for image and video recognition, as well as other tasks involving spatial data. CNNs are designed to process data with a grid-like topology, such as images, by exploiting the spatial correlation of the data. CNNs are composed of multiple layers, including convolutional layers, pooling layers, and fully connected layers. In convolutional layers, the network performs a convolution operation on the input data using a set of filters or kernels. The output of each filter is a feature map that highlights a particular aspect of the input data, such as edges, textures, or shapes. In pooling layers, the network reduces the spatial size of the feature maps by downsampling, which helps to reduce the number of parameters and computational complexity of the network.